Welcome and hello everyone. Today, our group will present our CHM256 assignment. Our chosen topic is the caffeine code. We will explore how the basic analytical chemistry is applied to perfect coffee we drink every day. It's so interesting, right? Let's jump to introduction. Coffee is the complex chemical matrix filled with over 1,000 compounds. In analytical chemical, we focus on studying specific analytes, mainly caffeine for bitterness and corallic acid for acidity. Quantity analysis allows food scientists to control this concentration for perfect flavor balance.
This slide outlines the chemical principles behind coffee analysis, which can be divided into three main parts. First, the chemical structure of caffeine. Caffeine is an organic alkaloid compound with the molecular formula CH10N4O2. It is primarily responsible for the bitterness and stimulating effect of coffee. Moving on to extraction mechanics. The process used here is solid liquid extraction. In this process, hot water functions as a polar solvent to dissolve caffeine and other soluble compounds from the coffee grounds. Finally, we look at extraction parameters and their impact on taste. When the contact time is insufficient, it results in under-extraction. This leads to low analyte recovery and produce a sour taste. Conversely, if the contact time is excessive, it causes over-extraction. This releases more bitter compounds and results in a bitter taste.
To analyze coffee compound, analytical chemists commonly use two methods. The first is volumetric analysis, also known as acid-base titration. This method measures the total titratable acidity in coffee by neutralizing the acid with a standard sodium hydroxide solution until the endpoint is reached using a pH indicator. The second method is high-performance liquid chromatography or HPLC. In this technique, coffee compounds are separated inside a chromatography column, allowing caffeine to be identified and measured accurately. Compared to titration, HPLC provides much higher precision and sensitivity, making it the preferred method for quality control in the coffee industry. Our laboratory procedure consists of three main steps. First, the coffee beans are ground uniformly and brewed using water at a controlled temperature between 92 and 96 degrees Celsius to ensure consistent extraction. Next, the brewed coffee is filtered through a 0.45 micrometer membrane filter to remove suspended particles that may interfere with the analysis. Finally, the clean coffee sample is analyzed. Depending on the objective, it is either injected into the HPLC system to measure caffeine concentration or tested using acid-base titration to determine the total acidity.
This data matrix shows how extracted time impacts the final cup. So the early stage, which is a 2 minutes, it can feel the low caffeine but the highly acidic. It can feel the sour taste. The second one is the perfect brew, which is a 4 minute. We can feel the sweet spot, which is the people likely to drink. If we over brew the coffee, it can feel slightly bitter or more bitter than the usual.
Hey coffee lovers, tired of the same old cup every morning? Well, today we're exploring 5 awesome ways to brew coffee right at home. Whether you're a beginner or a home barista in making, there's a method here for you. Let's get brewing. Number 1, drip coffee maker. First up, the classic drip coffee maker. Just scoop in some medium ground coffee, add water and hit start. It's convenient, consistent and makes enough for the whole household. Pro tip: use a paper filter for a cleaner taste or a reusable metal one for more oils and a bolder flavor. Number 2, French press. Next we have the French press. Simple, bold and a little bit luxurious. Coarsely ground coffee, hot water and a 4-minute wait is all it takes. Push down the plunger and you've got a rich, full-bodied cup. Perfect for slow mornings or a weekend treat. Number 3, pour over. Coming in hot or rather slowly is the pour over method. It gives you total control over water flow and brew time. Use a gooseneck kettle for precision and medium fine grounds. It takes a little bit more attention, but the result is clean, aromatic and incredibly nuanced. Number 4. AeroPress. Fourth on the list is the AeroPress, part science experiment, part magic trick. Coffee grounds, hot water, a quick stir, and then press. You can brew a strong shot like espresso or dilute it like an Americano. It's fast, portable, and easy to clean, making it ideal for travel or office coffee breaks. Number 5. Cold brew. And finally, for hot days or patient people, we have cold brew. Mix coarsely ground coffee with cold water, steep for 12 to 24 hours in the fridge, and strain. What you get is smooth, low-acid coffee concentrate. Serve over ice or mix with milk for a creamy, cold caffeine fix. So there you have it, 5 ways to brew coffee at home. Each one has its own flavor profile and vibe, so why not try a new one each week? Your perfect cup might be just a brew method away. Don't forget to like, share and subscribe for more foodie content.
Analytical chemistry plays an important role in both industry and everyday coffee preparation. In large coffee manufacturing plants, automated HPLC systems are used for quality control to ensure that every production batch has the same caffeine concentration and consistent flavor. In specialty coffee shops, baristas use a digital total dissolved solid or TDS. This portable instrument measures how light is refracted through the coffee to calculate the extraction yield instantly. By using this data, barista can adjust the brewing process and consistently produce high quality of coffee.
In conclusion, analytical chemistry serves as a scientific bridge that connects laboratory evaluation with everyday consumer products such as coffee. Managing chemical extraction parameters help optimize drink quality and ensure product safety. Furthermore, analytical methods play an important role in maintaining consistent coffee quality and enhancing consumer satisfaction.